So today we're going over chapter 10, section 2, find arc measures. So this is a lot of more vocabulary for the circles. We have the central angle. It's an angle whose vertex is the center of the circle. So ABC, that angle is a central angle. If you had another point, for example, guys, this point right here, let's call it point D. And we're going to draw a line to B. Now, if that other point of the circle, you would have another central angle. You would either have the other central angle being ABD, or you can have another central angle of CBD. You can call it also angle DBC. Remember, you can exchange the letters DBA, ABD, doesn't matter, CBA for the other central angle. And remember, all of the sides for this central angle are the radii. Sides are the radii. Now I'm putting it in plural because we made another central angle. Now we have arc. An arc is a broken part of a circle. You have minor arcs, which is an arc less than a half of the circle. You have a semicircle, which is half the circle. And you have a major arc, which is an arc greater than half the circle. For minor arcs, they're less than 180 degrees because that's half a circle. Remember, the whole circle is 360. So half the circle is 180. A minor arc, which is less than 180, is less than half. A semicircle is exactly 180 degrees because it is exactly half a circle. And you have a major arc, which is greater. So it's going to be greater than 180 degrees. Again, because it's bigger than half of a circle. We have this arc. So given segment DC is a diameter, arc AC is a minor arc, arc DAC, it's a semicircle, and arc ADC is a major arc. So remember, you always should go in order. The letters tell you the direction. So if they're telling us DC is a diameter, we know that's going to break the circle up into 180 right here and 180 right here, because the diameter is always from end to end crossing the center. They're telling us AC is a minor arc, which is exactly right here. Telling us DAC is a semicircle, which is what we drew originally. And we have ADC is a major arc. Now ADC is this arc right here, from A to D to C. Again, the order tells you the way it looks. And the arc can have 2 or 3 letters, okay? Here it shows us as 2 letters, and here it shows us as 3 letters. It just depends on the way it's written. It does not have an angle symbol, and it does not have a segment symbol on the top. But it can have 2 or 3 letters. All right, so we have the measure of an arc. The measure of an arc is equal to the measure of its central angle. So the central angle is the same as the inside angle. So again, the central angle is the same as the inside angle. If they're telling us that the arc AC is 50, this is the symbol for arc. In the other one, you didn't have it because it said the word arc. In this case, it doesn't tell you that is the word arc, it's just the symbol. So if the measure of arc AC is 50, we are able to determine the rest of the measures. So we have arc CAD, this measure right here that I drew in black. Now, how do I figure that out? That is a semicircle. So we know that it's going to be exactly 180 degrees. I'm going to write in semicircle. And then the last one, again, M, it stands for measure of arc, because we have the little symbol. I just want to write it down. And they want us to find the measure of arc ACD. So this one right here. Now that's going to be an addition. We're going to do 180 for the semicircle plus the 50 to find this measure. So the measure of this arc is going to be 230 degrees. So now we're talking about adjacent arcs. Just as a reminder, the word adjacent means right next to each other. So arcs that have exactly one point in common. The key word right here is exactly. So they cannot overlap. They can't overlap. So since they can't overlap, I'm going to write some adjacent arcs on the side so you guys have the examples. So for example, arc TQ and arc QR are adjacent. So is arc TS, for example, and arc TQ. The key part is that they must be adjacent. So for example, if we have arc RQ and ST, those two arcs, these are not adjacent because they must be next to each other, okay? So these two are not adjacent. Keep in mind how when I wrote the segments, we have TQ, which is right here, and QR, which is right here, so they share this segment right there. When I wrote TS, which is this one right here, and TQ, which is this one right here, they share this line right here. So that's what makes it adjacent. They share one common point, exactly one point in common, which in the blue case is the T, in the red case is the Q. So now we have postulate 10.1, which is the arc addition postulate. This is like the segment addition postulate. Let me write it down so I have it. The segment addition postulate and the angle addition postulate. So you guys have seen the same idea, but now we're going to do it in segments and arcs. So the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So what does that mean? For example, we have in the example right below us, arc ABC. Arc ABC is this whole arc right here. And they're telling us that we can add arc AB and arc BC to get it. And that is true as they are adjacent to each other. So now we have theorem 10.3, congruent circles theorems. This states that two circles are congruent circles if and only if they have the same radius. So circle A and circle B are congruent if and only if AC is equal to BD. That is the only way that the circles can be congruent, guys, because of the formula for the circles. The only way for a circle to be different is if the radius is different. Other than that, the circles are the same, again having the same radius. We'll do examples to show this, but this is just something good to know. Now we have congruent arcs, which is two arcs are congruent arcs if and only if they have the same measure and they are arcs of the same circle or of congruent circles. You can have the same congruent measures for the circles. Say you have this circle right here, you have an arc of 80, and then you have, again, you have to have the same radius and the same measure for it to be congruent. Again, circles have to be congruent, having the same radius or radii. This is multiple circles and multiple radius, so radii. And they have to have the congruent arc. So in this case, it's going to look like 80 and 80. Now, sometimes you may have a bigger circle with the same arc, but the radius is different. So it's not going to be a congruent circle. Okay? So this third circle I drew that's way bigger than the other two will not be congruent, as it is not congruent from a congruent circle. So it has to be the same circle or a congruent circle in order to be able to have congruent arcs. Even though they have the same measure, they are different. So theorem 10.4, we have congruent central angles theorems. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So a great way of seeing it is if you guys have a circle, like it's, well, better drawn on the right, obviously. And you have, let's say, two arcs like this, and these are going to be similar. You can think of them as vertical angles. So the only way the arcs are going to be congruent is if they have the same angle. So a lot of the times it's going to be a vertical angle. It's not always going to be the case, but it is usually how it's drawn at the beginning, so you guys can get used to the idea. So again, in this case, BC, which is this segment right here, is congruent to DE if and only if angle BAC is congruent to DAE, which are the vertical angles. So theorem 10.5 is similar circles theorems. It states that all circles are similar. Guys, all circles are similar. Please keep that in mind. All circles are similar. It doesn't matter how small or big it is, all circles are similar. And then you have two arcs are similar arcs if and only if they have the same measure. So you guys can have similar arcs if they have the same measure. So you can have a very small circle and a very big circle. And if they're both arc 80, I don't know why I keep using 80, but there are obviously similar circles. Those will be similar arcs. Again, all circles are similar. So if they have the same measure, the arcs would be similar. So here we have example 1. They want us to name two minor arcs, two major arcs, two semicircles, an acute central angle, and two congruent arcs. So two minor arcs are going to be anything less than 180. So I'm actually going to go ahead and name RC, which is this one right here. And I'm going to go ahead and name AR. Remember, you can always name them one way or the other. Two major arcs are going to be, for example, RD. RD is, oh wait, just kidding. RD is pretty sure it's a semicircle. So it's going to be RA, for example, could be a major arc. And so CR. Those are major arcs as they are bigger. We have two semicircles. So we can name one semicircle being AC. We can also name it CA, but that's going to end up being the same thing. Actually, if we name it CA, if we go this way or this way, it's still going to be a semicircle. It just depends on how you call it. Again, we know RD is also a semicircle, so I'm just going to go ahead and write it in. An acute central angle. An acute central angle is going to be angle ROA, for example. You can also name it if you want. If you named it as AOR, that's fine too. And then we have two congruent sides. In this case, we only know the semicircles. Don't assume that anything is a semicircle per se. So we can just say that, for example, arc ARC and arc CDA are congruent. In this case, I used 3 letters just to show you guys that in this case, by using 3 letters, I can make it go from A to R to C. And then I can make the other one go from C to D to A. The order will tell you the order it will be moved. And in this case, even though they both start and end with AC, we move 2 different ways. All right, so for example 2, we have give the measures of each angle or arc. So because we have the 30 degree and the 50 degree, the first thing I would personally do is fill in what I can from the diagram. So we know this is also going to be 50 because we know the central angle is the same as the arc, and that is a central angle. And then to find the remainder, I can do 50 plus 30. That's 80. So since we know half of a circle is a 180, I can do 180 minus 80. And I get that this remaining part of the circle is 100. Now, after I do that, I should be able to answer most of the questions. So WX, the arc, since it's the same as the central angle, it's going to be 100 degrees. Angle WOT, because it's the same as the arc, because that's a central angle, is going to be 50 degrees. Then we have XYT, which is X to Y to T, is this whole segment right here. So we're going to end up doing 180 plus 30. So we're going to end up with 210 degrees. And then lastly, we're going to find angle YOT, which is this segment right here. Now that is a straight line, and every angle that is a straight line is just 180 degrees. So that will be how we find those measures. All right, if there's no questions, guys, you do have homework on Canvas on big ideas. But that's it for today's notes.